What's going on, you guys? So today we're going to merge two sorted arrays. So we're given two sorted integer arrays, nums1 and nums2. We want to merge nums2 into nums1 as one sorted array. So we're guaranteed that nums1 is going to have enough space to add all the elements of nums2. So we're given four things. We're given nums1, we're given the number of elements in nums1, we're given nums2, and the number of elements in nums2. And so here would be the output for this one right here. So let's think about this, and let's do this by hand and see if there's any patterns that we can recognize and we could use in our code. Okay. Alright, so m equals 3 and n equals 3. Okay. So we know they're sorted, so that helps us. Let's start off by looking at some pointers. So we'll have one pointer that starts at the beginning of nums2 and one that starts at the beginning of nums1. So we could start by comparing two values. So 1 is less than 2. So maybe we'll move I, and we'll say there's only 2 m left. I'll compare 2 and 2. Do we want to merge the 2 from nums2, or do we want to move on? Let's move on for now. It's a little bit easier. So we'll say m is 1 now, and now we'll compare 3 and 2. And so now we want to merge 2. So we have to, what do we have to do? We have to move 3 to the 0 value, and we need to move 2 to this value. So we'll set I plus 1 equal to I, and we'll set I equal to 2. And we will increment I, increment j, and reduce each of these by 1. Okay, so now we're comparing 3 and 5. Yeah, so I is, wait, did I do that right? So we don't want to decrement I here. We have m. We have 1 left for m. So 3 is less than 5, so we'll move this here, and now this is 0. And so now when there's only elements remaining in nums2, we'll just merge the remainder. Say, okay, this is going to be 5, and this is going to be 6. We'll set this down to 0, and we'll be done. In this case, we only needed to move one element. We had, let me show you what we had. So we had to move 3, one element to the right. But here's the question: what happens if we have to merge an element, say on the first one? Then we're going to have to move all of the remaining values. Like, let's come up with an example. 4, 5, 6, and let's say our second guy is 1, 2, 3. Okay, so we would start off comparing 4 and 1. Oh, well now we have to insert 1 before 4. So we have to move all 3 of these elements back. That's going to get a little confusing. So let's try doing it from the opposite end. Let's start from the end rather than start at the beginning. So let's set j. Let's set j equal to the last value of nums2, and I equal to the last value of nums1. set these both to 3. Okay, so what would we do in this case? Oh, interesting. So we need to know where the current value in nums1 is, and we also need to know the last value, the greatest value in nums1. So let's use 3 pointers. So I will be the last value in nums1 that we need to be making comparisons on. We'll say k is the current value in nums1. So we're going to compare I and j, and the greatest one we're going to put at k. Okay, so we're going to compare 6 and 3. So we're going to make k equals 6, and we'll decrement k, and we'll decrement I. Okay, and we'll keep this here, and we'll reduce m by 1. There's only 2 remaining. Okay, now we compare I and j. Okay, so I is greater than j, so we're going to make k equal to I, so 5, and we'll decrement I and k, reduce m by 1. Okay, so now we compare I and j again. I is greater than j, so we set k equal to I, 4, and we decrement I and k. Okay, so now I is going to be -1, and k is going to be 1. Okay, so there's no more remaining for m. Okay, and so now for the remaining, wait, what happened here? Well, there's supposed to be one more element here. Okay. Wait, what just happened? 1, 2, 3, 4, 5, 6. So there's supposed to be 6 elements in our first guy, and it looks like I had 5 in there. But anyways, as you can see, well, let's do one more example. All right, we'll do one more. We'll do this same method on our on this one. Okay. Okay, double checking. We need 6 elements. 0. K will be the last one. J will be the greatest in nums2. I will be the greatest in nums1. Okay. So we're going to compare I and J. Okay, we're setting K equal to J. We'll decrement K. And we'll decrement J. We'll decrement N. Okay. So we've got 2 remaining in nums2. We've got 3 remaining in nums1. And we've decremented K by 1 value. So now we're going to compare I and J. Okay, so we're going to set I or K equal to J. 5. Decrement K. Decrement J. Decrement N. Okay. We're going to compare I and J. Okay, so J is greater than I is greater than J. So we're going to set K equal to I, 3. So we're going to decrement these 2. Okay. M is now 2. So now we're going to compare I and J. So this one can go either way, it doesn't matter. We'll set I equal to K, 2. Decrement both of these. Okay, now we compare I and J. We'll set k equal to j, so 2. We will decrement k, so we'll put k down to 1. J is now gone. 0, and k now must equal I. So we'll go like that. And so this will be our final return. Okay, so going from the end that way, we only ever have to change one element. Whereas if we start from the beginning and try and move our way back, we might have to shift nums1, all of its elements, back by 1. So that's just a little bit more complex. So starting from the end is a little bit easier. So let's think about what would pseudocode look like for that. Okay, so we'll have a couple variables. We'll have remaining 1, and this will be m minus 1. So in this case, m is 3. Remainder 1 will be the index of the last index for, so it'll be at 3. Remainder 2 we'll say is n minus 1. So that will put us right here, right? So it's putting us in the correct position to start. And then we want the last element to equal this right here. So what does that equal to? 1, 2, 3, 4, 5, 6 elements. So m plus n minus 1, right? So far last will equal m plus n minus 1. Okay, so we've got the 3 pointers that we're going to be using. So now the question is, how long will we be doing comparisons? So we'll be doing comparisons while both nums1 and nums2 have elements to be compared, right? So while remainder 1 is greater than or equal to 0, and while remainder 2 is greater than or equal to 0. And then what happens after one of them runs out? Yeah, what do we do after one of them runs out? Let's think about this. The question is, does it matter if remainder 1 runs out before remainder 2? Okay, let's try and think of an example. When would remainder 1 run out before? Oh, so if remainder 1 runs out before remainder 2, so here's an example. How would that happen? Okay. So here, all of the elements in num1 are going to be greater. So it's going to move, every single time we do a comparison, it's just going to move num1's values to the back. Well, actually it'll look like something like that, right? Because values are going to be overwritten. Well, this is a little bit, this won't confuse us. So 0, 0, 0. Okay. So remainder 1 runs out before remainder 2. So if that happens, then while remainder 2 is greater than or equal to 0, we'll just add the remaining values to nums1. Okay, what about if remainder 2 runs out before remainder 1? So let's say we got this one. Okay. So in this case, remainder 2 runs out. So we're gonna set this to 6, set this to 5, set this to 4, and then remainder 1 is still remaining. In that case, we don't have to do anything because the numbers are already sorted. If they were unsorted, we might have to do something to remainder 1, but because they're already sorted, if remainder 2 gets placed first, then we're done. We don't have to do anything. If remainder 1 gets placed first, then we need to fill in the rest of remainder 2. Okay. So this is when both are remaining. If only 1 is remaining, we only need to do anything if remainder 2 has remaining elements. Okay, and so what are we going to do? We're going to compare. We're going to say nums1 last, and we're going to decrement after every single one equals, we're going to do a comparison. If nums1 rem1 is greater than nums2 rem2, nums1 rem1 and decrement, else nums2 rem2 and then decrement. Okay, so if nums1 is greater than num2, we'll set the last element equal to the nums1 value and decrement remainder 1. Otherwise, if nums2 is greater than the nums1 value, we'll set the last value equal to nums2 and decrement the remaining 2 element. Okay. And then what are we going to do if we have to just fill in the remainder for remainder 2? We're going to say something similar, but just get rid of the if else. So okay, yeah. All right, let's see if that works. Let's convert that to Kotlin. Okay, we don't need to return anything. This unit element, that means that we're not returning anything. All right, let's see what happens. Oh. Huh. What's the issue here? Expecting a top level declaration. Okay. Okay, you guys, let's see if this works. All right, there you go. So the key really is to just work out the examples at the beginning. Just do it by hand and think about what would I be doing if these were Legos and I was just moving these around with my hands, like how would I do it? And then think about how you're doing it. Then you need to convert that to computer code. And so the important thing we realize is if we start at the beginning, it's going to be a little bit tougher because we have to move every single element. Whereas if we start at the end, we just need to move one element. We noticed that starting at the end was easier. So That has been merging a sorted array. All right, guys, stay tuned for the next one.